Download this code from codegive.com, link in the description below. OK, let's embark on a journey to create a dayz-inspired broken solo bass that, when 3D printed, could theoretically dispense, or at least represent, infinite cash. This is a complex project involving 3D modeling, basic electronics, microcontrollers, and a healthy dose of imagination. I'll break it down into manageable steps. Conceptualization: what is our infinite cache mechanism? Before we touch any code or design, we need a fun, and clearly unrealistic, method for our base to generate cache. Let's go with something a little satirical and dayz-esque. The zombie blood transmutation engine. Our base is a ramshackle research facility that extracts zombie blood and, through some fictional process, turns it into crisp, clean, but probably dirty in reality, dayz currency. Key components. Zombie blood collection. A section of the base dedicated to, visually, collecting zombie blood, maybe a fake tank or collection area. Transmutation chamber. A closed off section where the magic happens. Dispensing mechanism. A simple system to present the cache, real or fake, depending on your budget/intent. This could be a slot, a drawer, or a conveyor belt. Power source, optional but recommended. A visual representation of power. Maybe a small wind turbine model, a solar panel model, or a generator prop. Electronics and microcontroller. The brains of the operation, controlling the lights, sounds, and dispensing mechanism, if applicable. 2. 3D modeling, the visual foundation. We'll use Tinkercad for this tutorial. It's free, browser-based, and relatively easy to learn, but you could use Blender, Fusion 360, or your preferred 3D modeling software. 1. Base structure. Start with a base plate, drag a rectangular box shape onto the work plane. Make it a reasonable size, example 200 mm x 150 mm x 5 mm. Build walls, use more rectangular boxes to create walls. Think ramshackle, walls don't have to be perfectly straight or uniform. Add gaps, holes, and broken sections to simulate damage. Make sure the walls are high enough to contain the internal components. Roof, partial. Add a roof section using a rectangular box, but don't cover the entire base. Leave sections open to the elements. Supports, add some cylindrical or rectangular supports to reinforce the walls. Details, add smaller boxes, cylinders, and other shapes to represent debris, crates, barrels, and other clutter. Think about the story you're telling. What would be lying around a broken down research facility? 2. Zombie blood collection area. Tank, create a cylindrical tank, or a modified box to look like a tank, using a cylinder or box shape. Pipes, use cylinders to create pipes leading into the tank and out to the transmutation chamber. Bend the pipes using the bendable shape, under the shape generators category. Drips and splatters, add small, irregular shapes, spheres, cones, etc., around the tank to simulate blood splatters. You might want to use red filament for these. 3. Transmutation chamber. Enclosure, create a box-like structure to represent the chamber. Make it look reinforced, add extra layers of walls. Details, add vents, gauges, and warning lights. We'll handle the lights later with LEDs. 4. Dispensing mechanism. Slot/drawer, create a rectangular opening in one of the walls. Add a drawer using a box shape that can slide in and out of the opening. You'll need to leave enough clearance for the drawer to move freely. Asterisk optional conveyor belt, this is more advanced. Use a series of small, rectangular boxes connected with hinges. You can simulate hinges in Tinkercad, but you won't be able to move them after printing unless you assemble the base properly. A small motor can be added to actuate the belt, see electronics section. 5 Power source asterisk. Asterisk wind turbine, search for wind turbine in the Tinkercad gallery, or create your own using cones, cylinders, and other shapes. Asterisk solar panel, use a flat rectangular box and then add a grid pattern on top using thin rectangular boxes. Asterisk generator, a more industrial approach, use a cube and then add details like pipes and exhaust. 6 holes for electronics asterisk. Asterisk carefully plan where you want to run wires for your LEDs, sensors, and motor. Add holes, using the hole shape, in the walls and base to accommodate these wires. Make sure these holes are large enough. Asterisk add a cavity in the base to house the microcontroller, Arduino, ESP32, and battery. 7 Export as STL asterisk. Asterisk once you're happy with your model, select all the objects and click Group. Asterisk click Export and choose STL format. This will create a file that you can use with your 3D printer's slicing software. 3. 3D printing, bringing the model to life. 1 Slicing software asterisk. Asterisk use your 3D printer's slicing software, example Cura, Prusa Slicer, Simplify 3D. Asterisk import the STL file. Asterisk set the print settings. Asterisk layer height, 0.2 mm is a good starting point. Asterisk infill, 15 to 20% is usually sufficient for structural integrity. Asterisk supports, add supports where necessary, especially for overhangs. Asterisk material, PLA is a common and easy to use filament. Asterisk slice the model and save the G-code file. 2 Printing asterisk. Asterisk load the G-code file onto your 3D printer. Asterisk start the print. Asterisk monitor the print carefully, especially during the first few layers. 3 Post-processing asterisk. Asterisk remove the supports. Asterisk clean up any imperfections, sanding, filing. Asterisk optional, paint the model to give it a more realistic or weathered look. 4. Electronics, making it interactive. Now, let's bring our base to life with some electronics. We'll use an Arduino microcontroller for this example. 1 Components asterisk. Asterisk Arduino Uno, or similar microcontroller, the brains of the operation. Asterisk LEDs, red, green, blue for warning lights, indicators, and visual effects. Asterisk resistors, 220 ohm to protect the LEDs. Asterisk wires, jumper wires to connect the components. Asterisk small DC motor, optional for the conveyor belt or other movement. Asterisk motor driver, optional, if using a motor like an L298N to control the motor. Asterisk push button, optional to start/stop the transmutation process. Asterisk sound module, optional, a small sound module or MP3 player to play zombie sounds, beeping, etc. Asterisk power supply, asterisk a 9V battery or USB power adapter. Asterisk breadboard, optional but recommended for prototyping the circuit. 2 Wiring diagram asterisk. 3 Arduino code asterisk. 4 Code explanation asterisk. Asterisk const int red LED pin equals 13, defines the Arduino pins connected to the LEDs. Change these if you use different pins. Asterisk pin mode, red LED pin, output, sets the LED pins as output pins. Asterisk digital write, red LED pin, high, turns the red LED on. Asterisk digital write, red LED pin, low, turns the red LED off. Asterisk transmutation process, this function simulates the transmutation by flashing the LEDs in a sequence. You can customize this to create different visual effects. Asterisk start motor, int duration, activates the motor for the specified duration. Asterisk stop motor, deactivates the motor. 5. Upload the code asterisk. Asterisk connect the Arduino to your computer via USB. Asterisk open the Arduino IDE. Asterisk select the correct board and port. Asterisk upload the code to the Arduino. V-assembly and finishing touches. 1. Integrate electronics asterisk. Asterisk carefully place the Arduino, LEDs, resistors, wires, motor, if using, and battery inside the 3D printed base. Asterisk use hot glue or other adhesive to secure the components in place. Asterisk make sure the wires are neatly organized and don't interfere with the movement of any parts. 2. Add visual details asterisk. Asterisk fake cash asterisk print or cut out small pieces of paper to represent dayz currency. Asterisk blood splatters asterisk use red paint to add blood splatters around the zombie blood collection area. Asterisk rust and weathering asterisk use brown and black paint to create a weathered look on the base. Asterisk labels asterisk print labels with names like zombie blood transmutation engine, input, output, and warning, high voltage. 3. Test and refine asterisk. Asterisk power on the base and test the electronics. Asterisk make sure the LEDs light up, the motor runs, if using, and the cache dispenses, or is presented, correctly. Asterisk refine the code and the mechanical design as needed. 6. Code variations and expansions. Asterisk randomness asterisk introduce randomness to the LED patterns and motor behavior. Use the random function in Arduino to generate random numbers. Asterisk sound effects asterisk add a sound module to play zombie noises, beeping sounds, or other effects when the transmutation process is activated. You can trigger different sounds based on different events. Asterisk sensors asterisk add sensors, example a light sensor, to make the base react to its environment. For example, it could automatically activate the transmutation process when it gets dark. Asterisk networking asterisk use an ESP32 to connect the base to the internet and control it remotely via a web interface. You could even add a zombie blood inventory that updates in real time. 7. Important considerations asterisk asterisk. Asterisk safety asterisk be careful when working with electronics. Make sure you understand the basics of electricity and how to use the components safely. Asterisk realism versus fun asterisk this project is meant to be a fun and imaginative creation. Don't take the infinite cache aspect too seriously. Asterisk legal and ethical considerations asterisk if you're using real currency in any way, be aware of the laws and regulations in your area. Don't create anything that could be used for illegal or unethical purposes. Asterisk troubleshooting asterisk expect to encounter problems along the way. Be patient, research the issues, and don't be afraid to ask for help online. Code example, adding a sound module, DF Player Mini. To add a sound module, like the DF Player Mini, you'll need asterisk DF Player Mini module. Asterisk micro SD card, loaded with MP3 files. Asterisk speaker. Wiring asterisk. Asterisk DF Player VCC-Arduino 5V. Asterisk DF Player GND-Arduino GND. Asterisk DF Player TX-Arduino Digital Pin 10, or other available pin. Asterisk DF player RX-Arduino digital pin 11, or other available pin. Asterisk speaker-DF player speaker output. Code, add this to your Arduino code. Explanation asterisk. 1. Include libraries asterisk software serial.h, needed if using software serial for the DF player, and DF robot DF player mini.h, dfrobots library for the player. 2. Create software serial object asterisk software serial myserial, 10, 11, create a software serial port on pins 10 and 11, TX, RX. This allows you to communicate with the DF player without using the hardware serial port. 3. Create DF player object asterisk DF robot DF player mini my DF player, creates an instance of the DF player object. 4. My DF player.begin, my serial, asterisk initializes the DF player, using the my serial object. 5. My DF player.play, 1, asterisk plays the first MP3 file on the SD card, numbered from 1. Change the number to play different files. 6. My DF player.volume, 20, asterisk set the volume to 20. Important notes asterisk. Asterisk SD card format asterisk the SD card must be formatted as FAT16 or FAT32. Asterisk MP3 files asterisk place your MP3 files on the SD card. The DF player will play them in the order they are listed. Asterisk pin connections asterisk adjust the pin numbers in the code if you use different pins for the serial connection. This is a substantial project, and I encourage you to break it down into smaller, manageable steps. Start with the 3D modeling, then move on to the basic electronics and coding. Test each component thoroughly before integrating it into the final design. Have fun building your infinite cache days base.